In the vast, silent cathedral of the cosmos, Saturn has always held mysteries that beckon us to look closer. For centuries, this majestic ringed giant has offered only hints of the wonders hiding within its dense, swirling clouds and dazzling auroras. But every so often, a new eye opens to the universe, a tool so sensitive, so revolutionary, that it changes what we know. Today, we stand on the threshold of such a discovery, a moment of awe and scientific excitement made possible by the NASA ESA James Webb Space Telescope. For the first time, astronomers have probed deep into Saturn's upper atmosphere, revealing structures hidden far above the planet's famous clouds, complex formations unlike anything ever documented in our solar system. Picture this: Jupiter's sibling, Saturn, glowing softly against the black canvas of space, its rings casting shadows upon its golden cream atmosphere. While the iconic hexagonal storm at the planet's north pole has long captured our imaginations, it is Saturn's upper atmospheric layers, the ionosphere and the stratosphere, that now yield some of the most intriguing secrets thanks to Webb's unprecedented vision. Using the sharp, sensitive eyes of its near-infrared spectrograph, Webb has pierced through Saturn's veil, capturing something exceptional, a tapestry of dark, bead-like features embedded within radiant auroral halos. And deep below, a mysterious, asymmetric star pattern sprawled across the stratosphere. Both phenomena, so finely detailed, echo with the promise that even the well-studied can suddenly become thoroughly new again. Professor Tom Stollard of Northumbria University, a scientist at the helm of this investigation, described the moment of revelation with palpable astonishment. This opportunity to use Webb was the first time we have ever been able to make such detailed near-infrared observations of Saturn's aurora and upper atmosphere. The results came as a complete surprise. Scientists had prepared for broad, uniform bands of emission, perhaps mirroring behaviors observed elsewhere. Instead, what emerged stunned even the seasoned researchers. Fine-scaled, bead-like patterns and oddly lopsided stars, separated by hundreds of kilometers in altitude, yet possibly, almost impossibly, connected in origin. Let's take a step back and explore exactly what Webb has seen. At an altitude of 1,100 kilometers in Saturn's ionosphere, a realm of charged particles shaped by the planet's immense magnetic field, the telescope picked up unique near-infrared emissions. These emissions trace the chemical trail of H3+, a positively charged form of molecular hydrogen. H3+ isn't just fascinating for its chemical elegance, it is a vital marker for energy and motion in Saturn's atmosphere, acting as a kind of cosmic fingerprint for the processes occurring in this electrically active region. And yet, instead of the expected smoothly glowing arcs of auroral light, the data revealed dark beads scattered through the bright curtains of the aurora, as if Saturn wore a celestial necklace, beads of shadow among the shimmering glow. These structures persisted over hours, their placement constant, but they drifted slowly as time passed, hinting at underlying currents and unseen energies at play. Journeying roughly 500 kilometers lower, down into the stratosphere, a region where the air grows denser and chemical mysteries deepen, Webb uncovered another, even stranger formation. Here, it found the luminous trace of a vast, star-shaped pattern, stretching away from Saturn's north pole toward the equator. Yet this was no perfect celestial snowflake. Out of what ought to have been 6 radiant arms, only 4 shone forth. 2 were missing, lost, resulting in a strikingly asymmetric pattern, as if the universe were hinting, but not yet revealing the full story.
And the real marvel? Despite the immensity of the altitudinal gap, hundreds upon hundreds of kilometers, the features above and below appeared to mirror each other's positions. The arms of the stratospheric star stretched out directly beneath the points of the famous storm cloud level hexagon, that enigmatic 6-sided hurricane swirling closer to the planet's visible clouds. The beads in the ionosphere, those enigmatic shadows, lined up with the brightest of these star arms. Is this cosmic coincidence? or the surface hint of a grand, interconnected column stretching from aurora to cloud top. Scientists are left in awe, their curiosity sharper than ever. Professor Stollard and his team mapped these features with care, watching for any clues linking the unexpected patterns across Saturn's atmospheric layers. Their findings suggest that far from being isolated oddities, the bead-like and star-shaped phenomena may both be echoes of deep dynamic processes, waves, energies, and magnetic fields that sweep through Saturn's upper atmosphere. Perhaps these features are shaped by the same tidal forces or energy exchanges that produce the planet's remarkable auroras. Or perhaps they reveal long-hidden aspects of atmospheric circulation, physically linking the upper reaches of the ionosphere to the familiar hexagon storm much deeper down. Professor Stollard provided further perspective. We think that the dark beads may result from complex interactions between Saturn's magnetosphere and its rotating atmosphere, potentially providing new insights into the energy exchange that drives Saturn's aurora. Such insights are tantalizing for planetary scientists, for Saturn's magnetosphere is one of the mightiest in the solar system, a colossal force invisible to the human eye, but one that sculpts the movement of charged particles, creates powerful auroras, and, as now revealed, weaves patterns into the very fabric of the upper atmosphere. Yet, as astonishing as the discovery of the beads is, it is the asymmetric star in the stratosphere that most thoroughly demands explanation. Stollard speculates, the asymmetric star pattern suggests previously unknown atmospheric processes operating in Saturn's stratosphere, possibly linked to the hexagonal storm pattern observed deeper in Saturn's atmosphere. For now, these words capture both the thrill and the frustration of discovery, answers mixed with new questions, understanding locked in a dance with mystery. And there is one more almost poetic detail, the apparent alignment of features between these two atmospheric layers. Tantalizingly, the darkest beads in the ionosphere appear to line up with the strongest star arm in the stratosphere, but it's not clear at this point whether they are actually linked or whether it's just a coincidence. Such cosmic synchronicity inspires the imagination, inviting us to speculate about vast, column-like connections channeling energy or shaping patterns from the charged heights all the way down to the deep, churning clouds. Saturn's upper atmosphere has, until now, been largely impossible to study. Its emissions are faint, vanishingly weak even by planetary standards, and have eluded detection by ground-based telescopes and countless spacecraft. Webb's sensitivity has changed that. Its keen detectors, floating 1 million miles from Earth, have finally pierced this elusive realm. As Professor Stollard declared, Webb's incredible sensitivity has revolutionized our ability to observe these atmospheric layers, revealing structures that are completely unlike anything we've seen before on any planet.
But discovery is only the first chapter. The origins and dynamics of Saturn's bead-like and star-shaped features remain unsolved. They could hold the key to how energy moves through gas giant atmospheres, information with implications not just for Saturn, but for our broader understanding of planets everywhere. Perhaps, as follow-up observations are made, we'll start to see how these features change as Saturn's seasons progress. Right now, Saturn stands poised at equinox, a moment that comes just once every 15 Earth years when the sun shines directly above the planet's equator and the mighty rings lie edge-on to the light. As this orientation shifts, as day becomes autumn in the northern hemisphere, the atmospheric patterns may transform before our eyes, undergoing changes that telescopes like Webb are uniquely placed to observe. Professor Stollard summed up the urgency and excitement gripping the scientific community. Since neither atmospheric layer can be observed using ground-based telescopes, the need for follow-up Webb observations during this key time of seasonal change on Saturn is pressing. His team has already called for more time on the Webb telescope, hoping to delve deeper and watch as Saturn's hidden structures evolve. The initial revelations from Webb have already been shared in a paper published in Geophysical Research Letters and presented at the joint EPSC-DPS 2025 meeting in Helsinki, Finland, where planetary scientists from across the globe gather to trade notes, compare findings, and push forward the frontiers of our shared cosmic curiosity. So we look skyward, filled anew with wonder. Saturn, so familiar yet so full of surprise, stands transformed in the reflected glow of Webb's mirror. The bead-like shadows and lopsided northern star are reminders that the universe always holds more than we expect, and that new eyes, the likes of which Webb provides, can rewrite what we know in a single sweep. It is moments like these, standing at the edge of the unknown, seeing patterns never glimpsed before, that renew humanity's passion for discovery. The story of Saturn's complex upper atmosphere is only beginning. The mysteries revealed by the Webb telescope challenge us to keep asking, keep probing, and keep dreaming. Will we find the answers hidden in Saturn's shimmering auroras or in the asymmetric points of its stratospheric star? Only time and more daring voyages of light will tell. Thank you for joining us on this journey through Saturn's windswept skies, where darkness and light entwine, and each clue leads to an even grander question. Stay curious and keep looking up, because out there, woven into the cosmos, the next great discovery awaits us all.